Hello and welcome everyone to the world of Hack the Mountains 3.0 and this informative live session. I, Shubhangi Bhardwaj, on behalf of the entire team of HTM, would like to extend my regards and welcome you all to this community based hackathon where we regularly conduct webinars, workshops, HTM Qubits sessions like this one. All of this to strengthen your skills and help you perform better in the upcoming hackathon. Today, as you all know, we have gathered here for a very informative live session. We bring to you Mr. Aditya Jha, who is ML intern at AllCrowd. He was also GDSC Lead for session 2021 to 22 and Google Crowd ExploreML Facilitator. He will be sharing his experiences as a beginner who has successfully grown and had so much of an experience in our Qubit session, entering into the world of ML. Now, without any further ado, I would like to request Mr. Aditya to take over and better introduce himself.
Yeah, sure. Hello everyone. How's it going? I'm Jha. I am currently an intern at AIcrowd, and apart from that, I usually try to involve myself in the tech community, helping out students with machine learning and data science through being a GDSC lead before, and right now being a Google Crowdsource ExploreML Facilitator. So, like I have experience mentoring and guiding students in the field of machine learning. So yeah, perhaps you guys can share my screen if possible. Yeah, great. Thanks. So hello everyone. So starting off, let's talk about how you can enter into the world of machine learning. So the way this whole presentation is structured is that firstly I'll talk through what is the difference between software engineering and machine learning and talk you through what are the places where machine learning actually makes sense to use it. And then afterwards, in the second half of the presentation, I'll be talking about how you can go ahead and learn machine learning yourself and get acquainted with it. Machine learning personally is a technology that is very fascinating with a lot of great use cases, right? For example, you might have seen things like GitHub Copilot helping you all write code very easily. I personally use it and enjoy it a lot. That is an application of machine learning. Perhaps you might have used DALL-E before, which basically generates images from text, which is another very cool application of machine learning, and perhaps you might have used it before. So it is a ever growing field which has a lot of potential and a lot of upcoming jobs. And knowing about it will definitely help you in your job hunt or in your future entrepreneurial, pathway. But anyhow, continuing, this is a video that is very dear to my heart because this was my first introduction to machine learning, and they do it very perfectly. So perhaps if I can play this, do let me know if this is audible or not. Um,
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us.
Yeah, so hopefully that was a good video, and it talks about how machine learning impacts the world and how machine learning exactly works in a overview sense, and that is what I'm going to do next. So hopefully you grasped a little bit about machine learning from this video, but hopefully you can get more info. So, firstly, let's talk about what is the difference between software engineering and machine learning, right? So, when we talk about software engineering, we talk about creating applications, building them, deploying them. For example, you obviously have seen and used, apps like YouTube or Facebook or Instagram or stuff like that. All of that is software engineering. There, we structurally program our computer to do a specific thing, like, for example, creating a website or creating a mobile application or creating a backend service. And then we just push it out into the world, we deploy it, and users get to use it. Now, there is a new shift in the world, which is Software 2.0. The basic idea of Software 2.0 is that rather than hard coding and creating rules for our machines, we give our machines data and they can learn from data. And that is where the term machine learning comes from. Machine is learning from dataset and gathering insights and other sort of information to create rules out of it. So perhaps that might have not made a lot of sense to you yet, but let's talk about it in terms of a very cool example, right? So, talking about use case, let's, for example, think about it that you are an engineer at Healthify Me, something like that. And there is an ongoing demand that your product manager or your UI UX researcher has figured out that, hey, our user want us to, create a BMI tracker for them inside our application, something like that. So the whole premise of the BMI tracker is that you put in your height, your weight, and then it gives out your BMI. Obviously, the UI is going to be much better than this, but hopefully that use case makes sense. Now, as I talked before, there are two ways to go about it. Firstly, let's talk about the components that are required to build this specific feature, right? So, firstly, you have the mobile application part of it. For that, you might use perhaps Kotlin to create the front end part of it. Then you might create a backend via some framework. It could be Node.js, Django, or something like that. So the whole purpose of it would be that the front end will be handled by something like Kotlin, and the backend of showing things will be taken care by Django. But we also need to talk about how you're going to handle the BMI calculation part of it, right? For example, the user gives this as input their height and their weight, as shown here, right? You give your height and your weight, and then you get the BMI. What is the process between it? To do this, we can basically have two ways. Firstly, doing it via software engineering pathway, and the second would be doing it via machine learning pathway. So when talking about software engineering, what exactly will happen is that you will get as input your height and your weight. Perhaps it will work as an API where you get two inputs, height and weight. You run a command where you will say BMI is equal to weight divided by height square. That will be a rule. So whenever you get some input, height or weight, you will apply this formula and you will give out the answer. In this case, you can see that the software engineer has written the code. He has written the rule and defined the rule as BMI is equal to weight divided by height square. Right? This is something that the engineer has done and the engineer has written rules. But in case of something like machine learning, what we'll do is firstly, we'll go ahead and try to get data, and that is where a lot of like success of Google and other stuff and other big tech companies come, where they have a lot of data sets around their users, right? For example, how they type or what are the pages they like and stuff like that. And the purpose of that is that using that data, you can derive insights from the data set, right? So in this case as well, if you want to go to the machine learning pathway, what you will do is perhaps you will send out a survey where what you will do is you will basically go ahead and you will ask a bunch of users that, hey, can you please tell us your height, weight, and BMI, something like that. Afterwards, through the result of the survey, you might get a dataset like this, where you have features height, weight, and BMI. And there is 6 foot, 5 foot 11, 120, 180, 16.3, 34.0, right? So here, what exactly we have done is we have gathered the features and we have gathered the answers of the features, like that the features will give. Now what we'll do is we'll basically give the features and the answers to our machine learning algorithm. And then the machine learning algorithm will create the rules out of it, right? So for example, in case of this, the machine learning algorithm will go, it will see that, okay, these are our features, 6 feet and 120, and this is my answer, 16.3. And will try to derive some mathematical rule around it. Similarly, it will then go to the next data point and it will say 5 foot 11, 180. And then again, it will try to derive some, rule out of it. And so in the end, what exactly will happen is that, uh, you know, the machine learning model will come up with the rule as before, BMI is equal to weight divided by height square. Now, in this case, as you might have seen, right, what we are doing is we are basically providing machine learning algorithm the data set, but we are not specifically hard coding it with anything. We are not hard coding that BMI is equal to weight by height square. What we are saying is कि देख भाई machine learning, we are giving you this data set, अब बाकी का तू संभाल ले, please. Right? So you handle all of it. You figure out what the rule is and what everything is. Just give me the rule. And next what will happen is that you get the rule created by the machine learning algorithm, and now you basically use the rule created by the machine learning algorithm to create to get the BMI output. So again, the flow will remain same, where you will get the height and the weight from the user, but in this case, rather than hard coding anything, you basically will use the rule learned by the machine learning algorithm, and you will use it to get the BMI output. So hopefully that made a little bit of sense, right? And so similarly, there is like this is something that happens, but basically in software engineering part, what exactly is happening is that you get data from the user, so that will be your input, right? Height, weight, and all that stuff. Then afterwards, you will go ahead and you will like the software engineer will write the rules, and then it will use the rules to get to an answer, something like that. In case of machine learning, it will get the data, it will also get the answers, and it will come up with rules for you, right? So hopefully that made a bit of sense. Now there is a very big question we need to ask here, right? What should I use in this case? We talk about two different approaches, machine learning and software engineering. So perhaps someone from the chat would like to answer like what pathway seems better here. Anybody in the comments? Okay. Uh, one sec. So basically, what will happen is that software engineering pathway is a lot easier, right? For example, in the software engineering pathway, what we need to do is we need to go ahead and we need to, just write one line of code, which is BMI is equal to weight divided by height square. Whereas in machine learning case, we had to first ahead, go out and do the survey. Then we had to get all of this data set, and then afterwards we had to go ahead and train the model. It is a very iterative process, so perhaps you had to spend uh, 1 month to create a very good machine learning algorithm, and then you might have used it. So clearly software engineering methodology is much better in this case, right? So a question that you might want to ask is that what are the places where using something like machine learning makes sense, right? Because we saw that software engineering approach is clearly better here. Well, you might want to use machine learning in places where creating rules is very complex. So, areas where creating rules very complex, those are the places where you might want to use machine learning. So exactly talking about it, for example, let's say that you have a very big data set, right? For example, you can say here are a lot of features, and there are, like, this is just a small part of the data set, but let's say there are 1,000 features, right? So creating rules for those will be very difficult, because basically, you know, creating rules for those will be very difficult, because uh, it's a lot of features. So going ahead and trying to figure out that what should be the ideal weight given to every feature is very difficult. And so rather than that, what exactly we do is we use machine learning in this case, where we give all of this data set, all of these features and the answers to the machine learning algorithm. And what exactly happens is that the machine learning algorithm creates the rules for you, and so you don't have to hard code anything whatsoever, and you can just create the machine learning algorithm. Like, you can just get the rules out of it and then use it for whatever use case you want to use it for. Then there are a bunch of more ways you can use machine learning, right? Some other areas where machine learning actually makes sense. So firstly is computer vision. Computer vision is a field of artificial intelligence which is all about images. So anything you have to do with images or video or any such channel, you use machine learning for it, and specifically computer vision for it. So for example, if you have to classify between a dog and a cat, or you want to detect how the ball is going in a cricket clip, or you want to do something like what DALI does, right, where it gets the text and it gives out the image. All of that comes under the umbrella term of computer vision. So talking about the same thing, let's say that you want to do something like you want to get what the the uh, vegetable is from doodles, which is something that you can actually see live on quickdraw.com, which is a Google product. But anyhow, coming back to the topic, what you can do is, firstly, there is the rule based approach where you can go ahead and you can detect the edges and stuff like that, and then you can try to create rules out of it, that object dot height, if object dot height is greater than 10, then this might be a carrot or something like that, those kind of rules. But the issue with those will be that there can be a long chain of rules, and so it might get very complex, and it might be very hard to come up with those rules, right? So that is an issue. Apart from that, there is another issue that images can change a lot. For example, let's say that there is some use case of face recognition, right? In those kind of cases, the, like, brightness could change very well. So for example, let's say that you're using your face detection algorithm to unlock your face, and it does not work in the dark because you did not account for that while creating your rules, or you were using something else and it did not work out because the person was not using it like that, he was using it in some odd angle. So that's why the rule based approach for any image based task is very difficult, because things can change, right? And so that is where machine learning comes in. And around 2012, the concept of convolutional new networks came in. It's a technical jargon that you will learn in the future if you continue with this pathway. But it basically revolutionized the whole machine learning ecosystem and the computer vision ecosystem, and made CNN the primary way to do anything images. Um, talking about another use case is text. Anything to do with text, we use natural language processing, which is a type of machine learning, right? So how that exactly works is that you have natural language processing, which basically works with text or speech or anything like that. And it is the art of giving computer the ability to understand text and spoken words the same way as human do, right? For example, for us human, it is very easy to distinguish between a cat and a dog, because we have been doing it for a very long time and we have trained our brain in that capacity. But for machines, it was not very easy before machine learning, and now they can do it better than us actually. Similarly, for even text based stuff, It was very difficult for us to do such kind of things before, but now we can do it very easily. So let's say that you have some data set like this, right? A rule-based approach might be that you create some keywords, like for example, this use case specifically is around uh, mapping a review to a sentiment. For example, let's say that you have a website, and in website you have a place where you people can send down reviews for a specific movie. What you want to do is you want to basically do a sentiment analysis of it, where you want to get the sentiment of every review and figure out how many were positive, how many were negative, and stuff like that. In cases like that, we use NLP because this is a text-based system, right? So if you were to create manual rules out of it, what exactly would happen is that you would have a review, and you might say pick some keywords, right? For example, if the sentence has good, then you might say that it is positive. If a sentence has the word bad, then it is negative, stuff like that. But there are a few deal breakers here. For example, let's say for this it will work because there is good in this and this is positive, so it works here. But for something like this, like for example, it was so good at being bad, right? The sentiment though is negative, because we saw the word good here and bad here, it might say that it is neutral. It was okayish. Okayish might not be in our dictionary specifically, so it might not work. I slept through the whole movie. The playwriter should have been fired, right? Perhaps we might not have the word fired or slept as a bad word in our dictionary that we created, and so it might not give us negative at all, right? So there are a lot of complexities. There are complexities with, let's say that the text has something like this, for example, right? So for example, Aditya is good boy, and he is going to. So in this case, like we understand that he refers to Aditya, but the machine learning algorithm might not. So there are a lot of complexity with text languages as well, and so creating hard coded rules for them is very very difficult. And so in those cases we use machine learning algorithm, and specifically something known as RNNs, which is recursive neural networks, right? uh, Although that is out of scope right now if you're a ML beginner, so you don't have to worry about it a lot. But going on ahead, let's try to figure out, like next we are going on ahead, we will try to figure out, like which approach we should use, the rules based approach or the machine learning based approach, right? So for example, firstly talking about something like alphabetizing a list of song titles, right? What kind of approach you might want to use here? If anybody wants to answer or take a guess. Also, like I see a few comments where they are asking a few things about roadmap. Don't worry. Like I'm going to blast through this very very soon. Like this will be over in like 5 minutes, and then we'll talk about roadmap. Plus, I guess because there are less viewers here, you might get to have one-on-one with me where you can ask your questions and I will answer as many as possible. Right. So going on ahead. Yeah. Uh, yeah. Just before that, like which approach do you think we might want to use here, like for alphabetizing a list of song titles? Anybody wants to take a guess at it? Okay, I guess no one. Never mind. So for alphabetizing a list of song titles, we might use something like rule based, right? Because you can just try to sort it, and so that would be very generic software engineering use case, and so you might not have to use machine learning at all. In case of ranking a web search result, we use a combination of rule based and machine learning based approaches. Then talking about predicting house prices based on location. Anybody wants to guess for this? Like what might be perfect for this rule based approach or machine learning based approach? You can pick any of the option and type it in the comment section. Anybody at all? Yeah, cool. Very great, Krish Kathar. Exactly. Because we are predicting something. And apart from that, also, the thing is that there will be a lot of features, right? For example, there might be features like house, car, square feet, or number of bedrooms, or number of kitchens, or number of bathrooms and stuff. So creating rules for those will be very difficult. Plus, the thing is that these kind of prices can change a lot, right? For example, inflation might come in and prices might go down and go up. So rule-based approach don't work in this case, and so we might use something like machine learning. Exactly. Very awesome. Um yeah. So going ahead next, processing online payments. Again, to anybody in the chat, perhaps Krish. Okay. Yeah, absolutely right. It is. It is machine learning. No, sorry. Sorry. Uh, it is not machine learning specifically because rule based, right? The thing is that uh, processing online payments is sort of uh, back end side of things where a lot of things go ahead. So machine learning is not required there because the systems are already in place, and so it is pretty easy to do stuff. Um, Apart from that, classify an object in a photo. So we talked about this before, so this should be easy enough. Anybody wants to take a jab at it? Machine learning, great. Exactly, because like it's an image stuff. We talked about it that anything related to image, it is very complicated to create rules for it. So we use machine learning here. Exactly. Um, Talking about the next one. So there is no next. So to recap, we talked about the difference between rule-based approach and machine learning-based approach, right? So in rule-based approach, the benefit is that rules are already defined, and so we don't have to do a lot of iterations. We don't have to pick up the data set. We don't have to create pipelines and all that stuff. So a lot of complexity is removed, and we can just write code because that is something that all software engineers and including me we enjoy, right? Improvement comes from algorithms and networks, which is a very easy thing because getting data is harder than improving algorithms and stuff. Given with machine learning, the fact is that it learns patterns from data. So we talked about where it works, right? In places where writing rules might be very very difficult, and also improvements may be made from additional data, right? So that is another thing, and each of it has its own benefits. Now talking about idea to implementation, I'm just going to cut through this very fast because we have a lot of questions and I want to answer all of those. So talking about this, firstly, we like for example, let me make it clear via the BMI example, right? So firstly, we focus on the user. What does the user want? User wants a BMI tracker, right? It's very important for him to track his BMI. Suppose um, then we define the objective. The objective is to create a machine learning algorithm that can basically, do something like this task, right? Where we get the features and we get the BMI out of it. Afterwards, we go ahead and collect data, which we have done via, ML surveys and stuff like that. So we got the data. Then we train and test the model. We have not talked about this part specifically because of the less time, but we basically might train some model like logistic regression or something like that, and we might do this. Afterwards, we predict and evaluate, and we create the rule, and then afterwards we use that rule for the software engineering use case, right? Uh, yeah. So what can machine learning do else? So just talking about like some of these terms that you might want to know about, right? Which you might have curiosity about that how are these correlated, but you might not exactly know it. Artificial intelligence has everything to do with like computers displaying human-like intelligence. Machine learning is a subset of artificial intelligence which delves around using statistics and statistics to get data out of like insights out of data, and using it to train a machine learning model, and then using that machine learning model to create rules, something like that. Deep learning is a subset of machine learning, which basically deals with neural networks and stuff like that. And the whole purpose of deep learning is to work with images and text, as I said before, right? So that is deep learning. It's all based around neural networks, which is a type of architecture. If you don't know about it, you don't have to worry about it. You will learn it soon enough. But yeah, talking about what how did this sudden influx of machine learning in all of our lives come through, right? So the thing is that big data came in the picture. There were so many, there was so much data being generated in the past years, right? When YouTube came around, there were so many videos that were getting updated. Uh, we got better systems to generate, like, capture data from users, like how they type and stuff like that. So that became a good way for data to increase. Apart from that, the machine learning algorithms start to better due to research in academia, and so better and better algorithms started coming out. Plus, the technology around training machine learning algorithms, for example, GPU support, frameworks like PyTorch, TensorFlow, all of these came through, and that is how machine learning has grown to become very relevant in 2022. Just uh, coming back from 8 years ago, where nobody even knew what it was, right? It was very close dated, and only people in research knew about it. But it has grown quite rapidly because of the awesome use case in the machine learning world. But yeah, that's mostly about it in the terms of introduction. Now, I would like to talk about the machine learning roadmap now. So hopefully this is the part that I expect you all are waiting for, right? Um, so yeah. Um, Going through with it. Um, One sec. Let me share my screen once more, and with the Chrome tab machine learning that. Great. So hopefully you are able to see this. Also, I see a bunch of questions in the comment section. Again, it's just a matter of uh, you know, just 10 minutes, and then we'll go through it all of it together. Apart from that, perhaps Monica or Shubhangi can send you the link of the doc in the chat. Uh, Apart from that, um, yeah, going ahead, uh, coming to this roadmap, right? Firstly, we are going to talk about how exactly this operates. So basically, firstly, we start with data science, where we talk about Python first, right? So you need to learn Python and know Python as a back of your hand. So for that, we have Corey Schaefer's video, which are very awesome and very well, edited and well produced, and they are concise enough to give you a head start in your journey. So you can go ahead into this playlist and see all of his videos. If you see even the first six of it, it should be fine enough. Like, uh, it should work enough. So I guess the first nine videos, later ones are optional, right? After a point, obviously, you would want to go ahead and try to get a deep knowledge of Python, but for starters, this should work. After that, you can go ahead and so if you can see, this is how it looks. Python installation and setup is the first video, and then it goes ahead into the playlist. Afterwards, Corey Schaefer has another playlist, which is how to learn pandas. Pandas is a library for data frame manipulation, and the whole purpose of it is, to manipulate data frames. Data frames are basically the tabular data set that I showed you before, right? So, for example, even in that features, weight, height, and BMI1, we can manipulate those kind of data frames with pandas. So you can go ahead and learn this next through the playlist. Then you can learn Matplotlib, which is a very popular library which is used for visualization and going ahead and plotting graphs and figures and stuff like that. So that is something that you might want to consider next, which is pretty cool, and can help you a lot with the EDA part of it and stuff like that. Afterwards, there is the two very big specializations which are really really cool, which are basically machine learning by deep learning .ai, and then deep learning by deep learning .ai. So these two are very stellar courses which are taught by Andrew Yang. You might perhaps know him from his Stanford course. If you don't, then you will know him pretty soon. He is the superstar of anything machine learning and data science, right? Like almost everyone in the field of data science who is a data scientist has most probably seen his video and learned from it. So these two courses I would recommend for learning machine learning. And then deep learning. Deep learning is all about how to work with images and text and other stuff. So going ahead, we I would like to kind of give you an overview of the platform Kaggle, which is something you should definitely use during your journey as a data scientist. This is the place where all of the data scientists hang out, and this is the community for machine learning, right? So how exactly this works is that um, you go ahead and you register, or either you sign in. So I'll sign in instead with Google. You just do it quickly, right? So what you can do is that there are a bunch of competitions here. So while uh, learning machine learning, right, and you might have video here, recording here, so it might be a bit easier for you to follow along with this instruction. But what you exactly have to do is, while you're learning anything, for example, let's say you're learning Python and then you learn pandas, and in pandas you learn how to load a data frame into memory, right? What you will do is you will go ahead and you will go to Titanic. This is okay. One sec. Sorry. Um, yeah. Let me share another part of it. Sorry about that. Uh, Let me just share this one too. Uh, Let me just share my whole screen, if that works. So hopefully you can see my whole screen now, and this will make a bit more sense about whatever I was talking about. But basically, what you have to do is you will firstly have to go ahead, go to this link, go to kaggle.com. You can go via this, and then once you go here, you will get the option to register or sign in. This is a place where data scientists and machine learning engineers hang out. So this is a good place for you to build your portfolio, work with data sets, participate in competitions, and all in all learn a lot of data science and machine learning. So how exactly this happens is that you will firstly go ahead and go to competitions. Okay. In competitions, you basically go down and you go to Titanic dataset. Now, like, to make it easier, you can go ahead with this, and you can see that I have put in three links below here, right? So this is all competitions. So these are beginner competitions that will help you a lot to learn machine learning, right? So these three. First is Titanic, second is Titanic spaceship, and third is house price advanced regression techniques. So these are the three ones you want to watch out for, and these are pretty cool to start out with your journey with. So talking about how you use the Kaggle platform, let once you go ahead and click on this and you reach here, you will see a bunch of stuff. Okay, you will firstly see an introduction to how exactly all of this is working out. So you might see all of this text and how to make your first submission, which is a great video. You will see all of the other things and a bunch of stuff, right? So this will help you get in the hang of how Kaggle works and how Kaggle competitions work, right? You also have leaderboard here where you can see your ranking. You can basically make submissions, and then you can see your ranking here, and it's a good way to track your progress about how well your model is performing and stuff like that. You can go ahead to data set part of it, and you can get the data set. Now you can download the data set perhaps. So how it exactly works is, for example, you can see train.csv, right? You go and you click to train.csv, and then you see a bunch of features. So you see passenger ID, whether the person survived or not, what was the class, what was the name, sex, age, does he have any sibling, spouse, parent, child, ticket, fare, and all that stuff. So there are a bunch of features, and so this is the dataset you can use for creating your first machine learning algorithm. Apart from that, you can also go ahead to code and you know go here and then go ahead with most votes, and you will see a bunch of good and A class, notebooks. So, for example, there's Titanic Data Science Solution, Titanic Tutorial, Introduction to Ensembling and Stacking in Python, and stuff like that. So you can perhaps click one of it, and you can see a whole, um, Jupyter notebook, where you can read through it. You can see how they are thinking about the problem statement. You're also seeing the code they have written and stuff like that. So this could be something that you can try out. And a really big part of becoming a data scientist is to go to Kaggle and view other people's notebook and see how they write code, how they approach solutions and stuff like that. And that will most definitely help you out in your journey, right? So this is just one of the competitions. I have mentioned three. All three of those are beginner competitions that you might use to get your foot into Kaggle, understand about it more, and get your foot into machine learning and understand about it more. So hopefully that makes sense. From the start, I have talked about Python playlist videos, pandas playlist videos, matplotlib playlist videos that gets you covered through Python and all of its frameworks. Afterwards, I have talked about learning machine learning and deep learning from deep learning at AI courses. And this also covers all of the statistics and mathematics part, most of it. And so this would be pretty useful. Afterwards, you can go ahead and you can go to Abhishek Thakur. He is a Kaggle 4x Grandmaster. If you don't understand it, it is the highest, most honor a person can get into the Kaggle community. And he's also like NLP engineer at Hugging Face, which is one of the best AI startups to work for. And so he's a very experienced person, and his videos are very nice. So he has this specific playlist in association with Kaggle, which is 30 days of Kaggle, 30 days of ML, right? So the whole purpose is that in 30 days you will learn machine learning specifically, right? So that are all of these videos where he has getting started with Kaggle, how to say hello with Python functions, booleans, and other stuff, list, loop, and all this. So this could be a good way for you to get your hands dirty with machine learning. You can avoid all of this other stuff and start with this, and then afterwards go ahead and learn all of those things in deep and in in a nice way. But coming back to it, we are almost at the end of our roadmap. Hopefully, all of this made sense. Another thing, what you can do is that if you want to do, anything Kaggle, so for example, you want to participate in this, machine learning competition, and you want to work with the dataset. What you can do is you can go ahead and you can go to data. You can, you can go ahead to code. You can go ahead to new notebook, and it will basically get you a Jupyter kernel which you can use. So uh, Kaggle demon demonstration, right? And so the benefit of it is that the dataset will already be loaded. You can go ahead with this. You can go ahead and copy this path, right? You can go ahead and do this, and then go ahead and write something like df is equal to pd dot read csv, um, and then you can go ahead and see the fine, right? So you can do all of this on the cloud. You will not have any memory issues. You will not have to set up your own Python ID and stuff, and you can use it as a beginner. And so this is another very cool thing to do. You can see all of this, classes and stuff. You can use something like df dot columns to see all the features and stuff like that. So it's pretty cool and it's pretty nice. So anyhow, coming back to the roadmap part of things, I have talked about how to get started with Python, machine learning, deep learning. Uh, you have to do all of that alongside participating in Kaggle competitions and using the datasets from Kaggle to actually get hands-on experience, which is very, very important if you want to make it as a data scientist and a, perhaps intern at a startup or work at a startup and stuff like that. Uh, so yeah, going ahead, that was mostly from my side. You have received this log via the stream most probably. Now let's go ahead and perhaps go with the questions if that works.
Firstly, thank you for such an informative discussion. I'm sure everyone got to learn a lot today. Now, I think now we can move on to the questions. Okay, so we have a lot of questions you can also see. So we can begin with the first question. Can you tell the I think you already discussed about this. Can you tell the roadmap to learn ML?
Yeah.
So I think this has already been discussed. We can take the next question. What type of math do I need to have training in better understand PPC and machine learning?
Yeah, absolutely. So maths is a very important component of machine learning, right? And it's perhaps something that a lot of us fear because we are from the, computer engineering side of things, and so we like to code and we don't like to think about maths and stuff like that. But it's basically statistics, most of it. So what you need to learn is you need to not take everything in at once. You don't have to go ahead and firstly take an introduction to linear algebra class and learn all of it. What you need to do is you need to basically go ahead step by step. Firstly, learn how to go ahead and read a data set in. Then go ahead and learn why you want to perhaps learn something about how distributions work and a little bit of statistics and linear algebra and stuff like that. But you don't have to learn all of it at once. You need to go step by step and understand how things work. In terms of what maths you need to learn, you definitely need to learn linear algebra, very basic level of it. You need to learn what else? Statistics for all of the data stuff. For example, what is a Gaussian distribution, or why you need something like feature normalization and stuff like that. So that is the second prerequisite, and third will be learning.
Calculus maybe?
Yeah, differential calculus, which will not be required specifically a lot for machine learning side of things, but will most definitely be required in a very large amount for deep learning side of things because deep learning uses a lot of calculus, so a lot of differential equation and stuff like that. But yeah, these are the three things mainly.
Okay, we can move on to the next question. Shitad Singh writes, when do you think would be the perfect time to begin a test with a new machine learning tool?
So it depends a lot on what exactly a new machine learning tool is. So if you're talking about a new framework or something like that, I'm not sure you can like this question does not make a lot of sense to me. If you can perhaps word it a bit clearly. But if you're talking about a new machine learning algorithm, you can perhaps start with something basic and baseline, then go ahead and go it to an above iteration of it. So for example, if we talk about something like classification, you can try some basic, models like linear logistic regression in a classification type of use case. You can use something like logistic regression, then perhaps jump up to something like KNN, then decision tree, then random forest, then XGB boost. Basically, creating a clear baseline at the lower level, and then going ahead to a higher level and seeing if your far greater models are actually performing better than your baselines, because in a lot of cases there are chances of something like uh, you know uh, your your overfitting on your training data or something like that. So baselines help a lot. So hopefully that was the question.
Okay,
Yeah.
moving on to the next question. Ajay Kumar writes, I am a little bit confused that what should I learn first, ML or DL?
Yeah, so most definitely, always firstly get your hands strong on machine learning because a lot of the deep learning side of things are based on machine learning. So, firstly, like talking honestly, machine learning or deep learning is a very small part of the whole data science life cycle. A lot of the time goes into working with data sets, collecting data sets, and creating the model deployment pipelines. And machine learning is a very small part of it. If I talk about normal classification stuff, you can write 5 lines of code and you will create a machine learning algorithm. But so firstly get very comfortable with how to read in and manipulate data set, and then go ahead and learn about machine learning. Spend your time in machine learning, learn about how, like, about the mathematics behind machine learning. Specifically, if you want to go and make a career into deep learning, learn very well about how logistic regression works and how underlying it works, because it is a simpler version of neural networks, when neural networks are a step ahead of something like logistic regressions math. So learn that, and like spend about 3 months or 6 months, depending on your pace, on just learning machine learning and participating in some machine learning, uh, competitions. Like, for example, the first 3 datasets that I've provided in the roadmap sheet, those are all around normal tabular dataset, and do not touch even a little bit of deep learning, even a little bit of computer vision or NLP, because that is a step ahead of machine learning. And so most definitely get firstly your feet strong on machine learning and understand how it exactly works, then move on to deep learning. Hopefully that helps.
Okay. Next question. Apart from IT field, what are the applications of ML?
So, like, if I talk about the application of machine learning is useful in any place where data is, and data is everywhere, right? For example, in the field of agriculture, recently I was participating in a datathon, which was around predicting when wind turbines will fall, or like when wind turbines will fail, to prevent it from overcosting, which is application of it in the energy field, right? Artists are using it, like, for example, using DALI or stuff like that. Content creators are using it for generating image, so it has applications in the content creation field, right? So the application is anywhere where data is, and data is almost everywhere, so it can be used for in every single field, I guess. But yeah.
Okay. And now, since we are time bound, we'll be taking the last question. So the last question for the day is, how will you know which machine learning algorithm to choose for your classification problem?
So it's not more about knowing, it's more about experimenting. So what you want to do is you want to experiment as much as you can, right? So firstly, go ahead and try out different feature engineering things, like trying to generate as many features as you can, as many variety of features as you can. Try to go ahead and try a few different feature selection algorithms. Then try and go ahead and create some, like, try to select some basic algorithm, like, for example, logic regression or KNN classifier or something like that. Then go ahead to something like SVMs. Then go ahead to something like vision tree, then random forest, and XGBoost, and then perhaps something like LGBM. It depends a lot. Like, you have to try out all of these algorithms and figure out which one works best for your use case. If supposedly some logistic regression algorithm gives you about 0.98 accuracy, right? That should be good enough. You don't have to experiment any more than that. So firstly, get set a clear benchmark for yourself, that if I get an accuracy of this, I will leave it at that, and then go ahead and try to experiment and try to get more and more accuracy in the task you're trying to go for. But yeah, that was the clear.
Okay. So thank you for answering all the questions so patiently. And as I said before, it was a very informative session, and especially the roadmap, it was actually very helpful. I am sure all the viewers will be working on that. Now, thank you everyone for joining in with us today. For more information, you can visit our link, our website, which is showing in the banner. You can also follow us on Twitter, Instagram, LinkedIn, Discord, everywhere. The details must be shown in the banner. Now, the Hack the Mountain 3.0's main hackathon is held at the Manav Rachna International Institute of Research and Studies on the 17th to 18th September 2022. We hope to see you all there. Now, coming to a close, Mr. Aditya, would you like to say any parting words?
Yeah, absolutely. So, personally, in my journey, datathons and hackathons have been a very major part of who I am. Recently, I even won Smart in the Hackathon, and it was a very lovely experience. And so, any hackathon experience you can get, you should most definitely get it. It's a very wonderful opportunity for you. So, go grab it, fill the registration form. And obviously, thanks to the whole HTM team for bringing me here and giving me an opportunity to share my knowledge with all of you.
It was great having you with us today. Now, thank you again, everyone, for joining in with us today. Stay tuned. The hackathon is near, so stay prepped. See you next time. Thank you.
Thank you.